Hello and welcome back. Mrs. Saunders here. Today we're talking about angles and parallel lines. And we're going to learn how special angle types are related when two parallel lines are cut by a transversal. Last time we were together, we learned about angle pairs, and we learned that two lines cut by a transversal form the following angle pairs. We had corresponding angles, alternate interior angles, alternate exterior angles, and same side interior angles. But what happens if those two lines that are cut by a transversal are parallel? Now we get something even more special because we can add some measurement relationships to this. So when two parallel lines are cut by a transversal, we know that corresponding angles are congruent. So for example, angle 1 is congruent to angle 5. And we know that angle 4 is congruent to angle 8. Now that won't happen if these two lines aren't parallel. These two lines have to be parallel for this to be true. Okay, so when two parallel lines are cut by a transversal, we also know that alternate interior angles are congruent. Angle 3 would be congruent to angle 6. Angle 4 would be congruent to angle 5. Let's push them out. Alternate exterior angles are also congruent. So angle 1 is congruent to angle 8 and angle 2 is congruent to angle 7. And then finally our same side interior angles are, what do you think? Not congruent. They're actually supplementary, which means they add up to 180. So in this case, angle 3 plus angle 5 equals 180. And angle 4 plus angle 6 equals 180. Now this can all get really confusing, and we learned a lot even about linear pairs and vertical angles in a previous lesson. So let's sum it all up. Let's see if we can make ourselves a little bit of a cheat sheet, okay? So first of all, supplementary pairs. We've learned about two different kinds of supplementary pairs. One are the consecutive interior angles, for example, 3 and 5, and 4 and 6 here. And just to remind you, those are inside the parallel lines and on the same side of the transversal. We also learned a couple lessons ago about linear pairs, like 1 and 2 and 6 and 8. Those are also supplementary. They add to 180. And just to remind you, a linear pair, you can think about it as a line pair. And they share a side, come off the same line. So those are supplementary pairs. Now we've got a bunch of congruent pairs. Congruent meaning they have equal measure. For example, vertical angles. So angle 2 is congruent to angle 3. Angle 6 is congruent to angle 7 because those are vertical angles. Remember, vertical angles are formed by two intersecting lines and they're diagonal from each other. They form the same size V. Corresponding angles are also congruent. So angle 1 is congruent to angle 5, angle 4 is congruent to angle 8. Corresponding angles are on the same side of the transversal and sort of on the same side of their home line. Alternate interior angles are also congruent. Those are on the inside of the parallel lines, opposite sides of the transversal. And then alternate exterior angles, which are outside the parallel lines and opposite sides of the transversal. Hopefully that summing it up kind of keeps it all straight in your head. So now let's practice. It says in the figure, the measure of angle 2 equals 70. So find the measure of each angle and explain why. All right, so we're going to find the measure of angle 3, but what do we know already? We know that the measure of angle 2 is 70 degrees. Okay, so we're looking for the measure of angle 3 right here. And that's diagonal from that 70 degrees. Those are vertical angles. Vertical angles are congruent, so we know that angle 3 is also 70 degrees. Next up is angle 5. That's right here. So based on what we know so far, we can use this 70 degrees, and we know that these two angles, 70 and 5, those are same side interior angles. So the same side interior angles add up to 180. So that means that angle 5 is 110. And then let's try angle 8. Okay, I love vertical angles. See, angle 8 is directly vertical from this guy. So I can just take that 110 degrees and pop it over here. So angle 8 is 110 degrees because of that vertical angle. And then finally angle 1. We have a lot of options actually to find angle 1. Like look right here. See these two? That's a linear pair. So that means those have to add up to 180. We also know that these two, see this one here and angle 1, those are corresponding angles. So we could just take this 110 and move it up here because we know that corresponding angles are congruent. So that's 110. And just to double check, these two have to add to 180, and do they? They do. 110 plus 70 equals 180. All right, we're going to get a little bit more complicated here. In this figure, we got lines going all over the place, and we need to find the measure of some given angles. So the first thing you're going to ask yourself is, where are the parallel lines? Well, we got to look for the arrows that indicate parallel lines. See those down there? And so now these blue lines, those are our parallel lines, and then lines W and X, those are going to act as our transversals. All right, so what do we know so far? We know that the measure of angle 3 is 75 and the measure of angle 10 is 105. So let's put that information in there. And the first one we're looking for is the measure of angle 2. So let's see, here's 2. So the measure of angle 2 is 105. We know that for two reasons. One, these are, those are corresponding angles, so they have to be the same. And then these are same side interior angles, so they have to add up to 180. Okay, what about angle 5? Oh, I love these. Vertical angle, we can just move that down here. That's 105. Angle 12, well, that's way over here. But this 105, we can just pop that up here because those are corresponding angles. And then finally, angle 13, another vertical angle. We'll just move that guy down here, 105 degrees. Oh yeah, look at this. So 105, if you look at this 105 and this 105, those are alternate exterior angles. So those should be equal. Okay, we're going to add some algebra to this. It says solve for x and y. First of all, we're going to find our parallel lines and find our transversal. Now, let's see what we can do here. We need to solve for x, so we need to find two things that have an x in it. There's 8x minus 10, and there's 7x. Now, what do we know about those? Those are alternate interior angles, which means they're equal to each other. So we can just set them equal to each other and solve for x. Subtract 7x from both sides, add 10 to both sides, so x equals 10. Okay, now if x equals 10, I can plug that back right in here to that 7x, and then these two angles are a linear pair. Those have to add to 180. So we've got 7x here, and we know that x equals 10, and then 6y plus 20 here. Add these two angles together, and you get 180 because it's a linear pair. Those are supplementary. And then we can solve for y. So 90 plus 6y equals 180. Subtract 90 from both sides, divide by 6, and you get y equals 15. All right, only two more. So here's another set of parallel lines cut by a transversal. And let's go ahead and solve for the x's first. We've got an x here and an x here. Those are corresponding angles, so those are congruent. They're equal to each other. So set them equal to each other. Subtract 9x from both sides and add 1 to both sides. Divide by 2, and we've got x equals 11. So we're going to take that 11 and plug it right back in here for this x. And then what do we know about these two angles? They're sharing a line, they share a side. Those are a linear pair or a line pair, so they add up to 180. So let's see, here's our top angle, and there's our bottom angle. Those add together to 180, and we can combine like terms. We'll subtract 115 from both sides, divide by 5, and you get y equals 13. All right, one more problem, and this one's kind of weird. It says find the measure of angle 1. Here's the problem. We've got our parallel lines here, right? But we've got this transversal that doesn't really go anywhere past that line, and this transversal that doesn't really go anywhere past that line. So we're going to do a little trick here, and we're going to add this extra line in between. It's called an auxiliary line. Now we can start solving for angle 1. We got to solve for this whole thing here. But let me erase those yellow lines here real quick. Okay, now that's cleaned up and we can see what we're doing. So what do we know about angle 1? Well, angle 1 is made up of these two angles here. And this top one here corresponds to this angle here. So actually I know that this guy here is 50 degrees. And this one is a same side interior angle with this one. So these have to add up to 180 degrees. So that's 80. So if we know that the top angle is 50 and the bottom angle is 80, we add those together and we get the measure of angle 1 is 130 degrees. So a lot to process in that one. Take it slow, and I know you can do it. Thanks for being here.